The purpose of this lesson is to review the previous 3 lessons on working with exponents by simplifying 2 complicated expressions. And for this first expression, we're going to simplify it 3 different ways. For the first way, we're going to simplify the fraction inside the parentheses first. We look at the x's, we apply our rule, we subtract the exponents. 4 minus 3 is 1, and we get x to the first power, which is just x. And then for the y's, we do -3 take away 5 is -8, but we prefer to write it as y to the positive 8 and place it in the denominator. And then for the rest of the problem, where we have the quotient taken to the -3rd power, we're going to apply the power of a power, as shown with the red marks. Well, x to the first taken to the -3 is 1 times -3, which gives us x to the -3. And for y to the 8th, we multiply 8 times -3 to get -24. And then, of course, we can use our rule that the negative powers in the numerator can move to the denominator and become positive, and likewise the y to the -24 in the denominator moves to the numerator and becomes positive, and we've simplified the expression. And now we're going to do the same expression another way. This time, we're going to flip it. Instead of having the whole thing to the -3rd power, we're going to have the reciprocal of the whole thing to the positive 3rd power. So we simply reverse the numerator and the denominator. And then we do 3 take away 4 for the powers of x to get x to the -1st, which we choose to write in the denominator as x to the 1st, or just x. For the y's, we do 5 take away -3, which of course is the same as 5 plus 3, which is 8. So we have y to the 8 in the numerator. And we now have a positive 3 on the outside. And we do 8 times 3 to get 24, as shown with our red marks. And 3 times the implied 1 for x to get 3. And the good news is our simplified answer is the same as it was the first time we did it. And now we're going to simplify this problem by one more method. And for this method, we're going to distribute the power, -3, throughout our fraction inside the parentheses. That gives us, of course, 4 times -3 for x on the numerator. -3 times -3 to make y to the 9th, also in the numerator. And in the denominator, 3 times -3 gives us x to the -9th. And 5 times -3 gives us y to the -15th. And now we're going to simplify again by moving negative exponents from the numerator to the denominator and vice versa. So it gives us x to the 9th, y to the 9th, and y to the 15th in the numerator, and just an x to the 12th in the denominator. And our final step, 9 minus 12 is -3 for the powers of x, which we choose to write as x to the 3rd in the denominator. And for the y's, which were both in the numerator, 9 plus 15 is 24. And for the 3rd time, we get y to the 24th over x to the 3rd. And let's do one more complicated expression. We're going to start by doing the product of a power in all the numerators and denominators of these 2 fractions, giving us a to the 6th n to the 10th in the numerator of the first fraction, a to the 21st n to the 6th in the denominator of the first fraction. For the second fraction, we have some negative exponents. Well, again, the a is like a to the 1st, and 1 times -3 is -3. For the n, it's n to the 2nd taken to the -3 power, so we do 2 times -3 to get -6. For the a to the -2 in the denominator, it's -2 times 4 to get -8. And 2 times 4 for the power of n makes n to the 8th in the denominator. And now we simplify each fraction. For the n's, we get 10 minus 6 is 4. And for the a's, we get 6 minus 21 is -15. So we write it on the bottom as a to the positive 15. In the other fraction, it's -3 take away -8, which makes positive 5. And -6 take away 8 is -14, so we write it in the denominator as n to the 14th. And now we're running out of room, so we're going to do 2 steps at the very bottom. We're going to write what we know about multiplication of fractions to write a to the 5th times n to the 4th in the numerator, a to the 15th times n to the 14th in the denominator. And in this case, the denominators have the larger exponents. 15 minus 5 is 10, so we place it in the denominator. 14 minus 4 is also 10. We place that in the denominator. Yes, we could also write this as a to the negative 10th times n to the negative 10th, but I'm of the school that prefers to write my final expressions without negative exponents, so I write 1 over a to the 10th times n to the 10th. Here's a summary of our rules for working with exponents and variables. First, exponentiation. Then, the power of a product. The third on this page, product of two powers with equal bases. And finally, the power of a power. But wait, there's more. How about the power of a quotient? Or the quotient of two powers with equal bases. And don't forget that for any non-zero number, x to the 0 power is equal to 1, and negative exponents are defined as x to the opposite of n is equal to 1 over x to the n.